This is Algebra 2, Lesson 1, 2, Properties of Real Numbers. We have two objectives for this lesson. One is to be able to graph and order real numbers, and the second is to identify properties of real numbers. So let's begin by talking about real numbers. Mine's going to look a little bit different than what you have in your notes, but make sure you can follow along. The first one we're going to talk about are natural numbers, and natural numbers are the numbers we use to count 1, 2, 3, 4, 5, etc. So make sure you write down that definition and examples of those numbers they have in the green. Um, the next one we have are whole numbers, and whole numbers are natural numbers and zero. So it's exact same thing as natural numbers, but there is a zero. A zero is included in that set as well. After that, we get into integers. Integers are the natural numbers and their opposites and zero. So this is where you get -5, -4, -3, 0, 1, 2, 3, all those numbers. Then we have rational numbers, and rational numbers are numbers that can be expressed as a ratio. So make sure you get that down. Expressed as a ratio. Now some decimals are natural numbers, as you see in there, 0.222. That can be written as 222 thousandths. Also numbers like 0.8 repeating would be a rational number because that is really 8/9. So anything that can be written as a ratio, that is a rational number. And then lastly, we have irrational numbers. Those are numbers that cannot be written as a ratio. So a common example is pi, 3.1415, etc. Our square root of 2 is a very well-known irrational number. E, which we'll talk about at some point this year, is an irrational number. And really any, there's a large list of them we'll get into as the year goes on. Okay, so one thing you're going to need to be able to do is to determine which sets would best describe which situations. So the first question is, which set best describes the amount of sleep you got last night? So if you think about it, last night I got 7.5 hours of sleep. Maybe some of you got 8, 9, maybe some of you got 6, 5.5, etc. You want to think about what numbers in this set are going to best describe that. Well, I didn't get a full 8 hours or a full 7 hours, which means I'm not talking about integers. And if you're not talking about integers, you're also not talking about whole numbers and natural numbers. Those numbers can express what you got for sleep, but they can't include all of the options that we have. So our best option on this is actually the rational numbers, because I didn't get a whole number. I got part of an hour of sleep. So in this example, we're going to have the rational numbers. Make sure if you're using examples to help you figure out a question like this, that you think of all the different possible options that you can have. You have to think about, can you have negatives? Can you have positives? Can you have fractions of hours? So the next one, I want you to try and answer these ones on your own. Would you pause the video now, see what you can come up with, and then when you're ready, press play and see what I got. You can see both my answers to these. On the top one, I had the example of -6. The opposite reciprocal of that would be 1/6, which is a rational number. 5, the opposite reciprocal of that would be -1/5. So I think the best set to describe those would be rational numbers. The time it takes to drive to school. This one varies on what unit you're talking about. So maybe it takes you 25 minutes, maybe it takes you 17 minutes. If you're talking in terms of minutes, you would probably say that it's a natural number. But if I told you it took me half an hour to drive to school, in that case, we're going to be getting into rational numbers. So it kind of just depends on the units. When you get across a question like this, it should be more specific on time units. And so pay attention to that as you're answering these questions. So this could maybe imply that it's rational. All right, so graphing and comparing real numbers. This is a review for you guys. You've done this before, but basically what I want you to do is to take these numbers and graph them on a number line. I'll go through the first few with you. The first one says square root of 2, -5 halves, and 2.6 repeating. So I would start with whatever you know right away. You should hopefully know -5 halves off the top of your head. That's -2.5. And I think it's easier to get these all into decimals or a decimal approximation as you're graphing them. So -2.5, that's going to go right between -2 and -3, right in the middle. Now, when you put that on there, make sure it's in the original form, -5/2, not -2.5. Then 2.6 repeating, that's a pretty easy one to find. It's going to be right there. The one you may not know is square root of 2. If you don't know what that is, think about, okay, the square root of two perfect squares, one above it and one below it. So the square root of 1 would be below it, and that's 1, and the square root of 4 is the next perfect square, and that's 2. That means that the square root of 2 is going to be somewhere between 1 and 2. Since it's square root of 2 and not the square root of 3, you can probably guess it's going to be closer to 1 than it would be to 2. So you can approximate that on there, maybe about right there is your square root of 2. Pause the video, do the next two on your own. This first one, you should have gotten the square root of 8 is greater than 11/4. If you're approximating the square root of 8, it's going to be 2 point something, and 11/4 is 2.75. So on this one, I actually went to my calculator, used it to help me, typed in the square root of 8, put in, hit enter, and I got 2.828 as the decimal approximation, which is bigger than 2.75. And then on B, I thought about this, a negative square root of 26, well, that's really close to the negative square root of 25, which is -5. And it's going to be in between negative square root of 25 and the negative square root of 36. So somewhere between -5 and -6, meaning since these are negative numbers, that should be bigger than -6.25. Hopefully this is a review for you guys and you're feeling pretty confident about this so far. All right, properties of real numbers. This is our last slide for our notes today. They're pretty short and to the point. You have seen these many, many, many times. So let's start with the first one, closure. You need to write that. You need to write in the addition and multiplication properties. Closure means that if you have two real numbers, their sum is also a real number in addition. And the multiplication property of closure would be that the product of two real numbers is also a real number. This is really important in mathematics. The next property is the commutative property of addition and multiplication. So the commutative property says that if you're adding two numbers, A and B, A plus B is the same as B plus A. I like to think about it commuting. I commute to work every day. I start at home, which is A, and I end up at work, which is here, B. And then at the end of the day, I start at work, B, and I end back at A. So you're commuting, you're going back and forth between two places, so the order switches. Same thing for multiplication, it goes AB and then BA. The next one we have is the associative property. The associative property says that if you have the sum of two numbers, A plus B, that plus C is equal to A plus the quantity B plus C. Multiplication says the quantity A times B, all times C, equals A times the quantity BC. Now, the way I remember this one is that you associate with different people depending what classes you are in. Say there's three of you, you're best friends, but in one class, maybe Sally and Susie are together, that's A plus B, but maybe Jenny isn't in that class with them, but she's still part of their friend group. Now, they're still all three friends, even though only Sally and Susie are in a class together. Then maybe your next hour, Sally and Jenny are in a class together, so they're grouped differently, but once again, all three are still friends. So it's who you associate with. When you take the sum of three numbers like that, and you group off two, you don't change the sum. And the same thing works for multiplication. Our next one is the identity property. The identity property says that when you add, for addition, it says that when you add nothing to a number, you get the same number. So 0 is what we call the additive identity. Now, multiplication, it's quite similar, but instead we have the multiplicative identity. So you want to think about can you multiply a number by and not change it? Well, if you multiply by 1, the number stays the same. So A times 1 is equal to A, and 1 times A is equal to A. So multiplication, your multiplicative identity is 1, whereas in addition, your multiplicative identity is 0. They don't change the identity of the number when you perform an operation on it. Now, inverse. This is a big topic in Algebra 2. Inverse is something you can, two numbers is something you can combine with another number to get the identity. So A plus negative A is going to get you 0 because 0 is the additive identity. And A times 1 over A is going to get you 1 as long as A is not equal to 0. That's kind of important because you have a fraction with a real number in the denominator there. So the Inverse is whatever you can combine with a number using your operation that you're talking about, whether it's addition or multiplication, to get the identity for that number. Okay. The next one we have is distributive property. You've seen this one many times. If you have A times the quantity B plus C, you can distribute that A to both pieces and you get AB plus AC. So what I want you to do is take a look at these three problems on the bottom of your notes packet and see if you can identify what are the properties shown in each example. Pause the video and see if you can name them. So if you take a look at this first one, originally when you see the parentheses like that, you may have thought that it's the associative property of addition. However, if you look, what's really happening is the 2 is switching places with this whole quantity 5 plus 4. So really it's a commutative property. They're switching locations. So you want to think about what's in that parentheses right there. It's one number together. It's an item because it's grouped together already. And that item is switching places with the 2. The next one is the associative property of multiplication, and the last one is the identity property of multiplication. You can abbreviate, just be careful in your abbreviations. Associative property should be abbreviated as ASSOC. Make sure you're very careful with that one. All right, that was the end of lesson 1-2 for Algebra 2. Our objectives were to be able to graph and order real numbers and to identify properties of real numbers.